30 to 35% of forests may undergo change in the next 30 to 50 years. Okay, if there is a warming of 2 degrees or 3 degrees by 2050, can evergreen forests in the Western Ghats survive?
What could give them the assurance that it's a good investment?
For any rupee or a dollar or a pound invested, if you invest in forestry, you get 10 times more ecological benefits, livelihood benefits, benefits for the poor, and global benefits. If you ask me, one of the biggest challenges India would face is increased high intensity rainfall events leading to floods, damage to crops, property, homes, bridges, everything.
How many forests, how many trees is it required for us to reach an ideal state?
Anywhere between
This is the Boring Climate Podcast, a platform where we encourage serious climate conversations. Today we're exploring a vital piece of the climate puzzle, the potential of India's forests as climate change mitigators. And we have the perfect guide. Our guest today has been studying climate change since long before it became a headline, and his decades of research has placed him in the top 2% of the world's most cited researchers, according to the University of Stanford. We're incredibly honored to welcome Dr. NH Ravindranath, a professor retired at Center of Sustainable Technologies in the Indian Institute of Science. He began his journey with a bachelor's and master's in agriculture and a PhD from IIT Bombay. His research, advocacy, and publications focus on GHG emissions, carbon sequestration modeling, vulnerability assessments of forests and agroecosystems, and so many other dimensions of the climate problem. He is an author of 12 IPCC assessment reports on climate change and has served the UNEP, the UNFCCC, and several other global bodies in various capacities. Welcome to the show, sir. Thank you for joining us. So, we'll start with the impact of climate change on India. By now, it's established that the Earth's climate is changing, and we feel these changes in our daily lives. So, early summers or prolonged rains, these are something that we've now started getting used to. How vulnerable is India specifically, and are there regions in India that are particularly more vulnerable than others?
Of course, firstly, we as normal citizens, we feel it's some days too hot, too cold, or there's a drought, and or there is a flood somewhere. But there are also other impacts on forests, biodiversity, oceans, marine ecosystems. Those are not visible to us, but it's happening. But it's true in India. India, such a large country with such very diverse ecosystems, diverse socioeconomic systems. So, given that obviously there will be some regions which are more vulnerable than other regions which are relatively less vulnerable. So, there are many factors that determine vulnerability. We can go into that in the coming minutes.
Sure. So actually, a lot of this was covered in the 2021 All India Vulnerability Assessment report that you were also a part of. One of the things that report revealed were the reasons that different regions are vulnerable. Another thing it revealed that one of the drivers of this vulnerability is low forest cover and the poor adaptive capacity of our agroecosystems. Specifically regarding forests, what makes forests so crucial to make us less or more vulnerable? What are the factors that are affecting forests?
Yeah, we conducted a study at the national level, both comparing the states on their vulnerability, some sort of a profile or index, and within a state, ranking the districts. So we rank the states on vulnerability index, and within Karnataka, Tamil Nadu, whatever, within the state, rank the districts. And we also ranked all the 800 plus districts also. So we have a nice map which shows which are the regions where there is a larger concentration of districts which are highly vulnerable. You can rank highly vulnerable, moderately vulnerable, low vulnerable. We have a you know five rank of 3 or 5 classes of vulnerability. So if you look at that, the most vulnerable districts, the concentration is largely in Orissa, Jharkhand, Bihar, Assam, some parts of West Bengal. So that's of course vulnerability is determined by the indicators we use for what's called sensitivity of communities or ecosystems on the one hand, and their adaptive capacity, sensitivity to changes in climate, and their capacity to cope with any drought, floods, or cyclones or hurricanes. So, given that there is a concentration of highly vulnerable districts, in these states. If you ask me some other state which are which are low vulnerability like Himachal Pradesh, Tamil Nadu, Maharashtra, Kerala. Obviously, I think you can make out there is some socioeconomic levels of development also seems to indicate, access to crop insurance, access to alternate livelihoods, access to irrigation. All of them contribute to that. Apart from that, one of the factors we also found was presence of forests. Normally in a district, hectares per thousand people. How many hectares for thousand or million people in a state or a district? So if you look at that, forest is one of the things I would say. If you are looking at, given the agriculture is a main livelihood in most states, lack of irrigation is a dominant one. But after that, there are presence or absence of forests, and the extent of forests accessible to communities is important. Firstly, forests provide alternate livelihoods. They provide nutrition. They collect a lot of fruits and leaves they eat. Communities, they get seeds like sal seeds, sal leaves, mahua seeds, and there are so many orange. There are so many forest products which are collected by communities, especially during a drought year. They depend on forest for livelihood. Number one. Number two, I think forests also impact water availability in the region, the percolation of water into the soil and its availability downstream. So, given that, I think livelihoods and water availability and additional source of income or diversified source of income makes forests as one of the critical indicators or drivers of vulnerability. But lack of irrigation, other poverty levels, they are also driving factors to determine a district or a state as highly vulnerable or moderately vulnerable or least vulnerable.
Right. And would you be able to tell us a little bit more on these terrestrial ecosystems? So, forest is probably one, plantations, even land itself. All of this have some carbon sequestration or storage potential. How does that work? And how do we know how much forests are storing or how much plantations are storing?
In India, for example, the total geographic area is around 320 million hectares. Out of that, about 70 million hectares under forests, about 160 million hectares under cropland, some 30 million hectares under grassland, some 10 million hectares under towns and cities, and rest is all like snow deserts and so on and so forth, snow-clad mountains and all that. We have made an assessment of the carbon stock in the forest land, in the cropland, grassland, and also in settlements, rural, urban settlements, towns, with cities and villages, and also grasslands. And of course, the- simply because there is almost 170, 160 to 170 million hectares under crops, that dominates the carbon stock because soil has a lot of carbon than the trees. Even in forests, now soils have almost double the carbon stock that you see above ground. Normally, we think forest means only trees, the trunk, the branches, and the leaves. But there's so much roots and soil organic carbon, so that carbon becomes very important in the cropland soil carbon and in grassland soil carbon. Grasslands may not have trees, but they can have as much carbon as forests. A good grassland can have more carbon in the soil than even in forest. So the soil carbon becomes very critical for global climate challenge. Also, for a given ecosystem, it could be cropland ecosystem or a grassland or forest land. So both soil and biomass are critical in storing carbon or also in emitting carbon. Also, if you disturb the soil, if you go and plow a grassland, and all the carbon in the soil will be oxidized. Or if you cut forests and you burn a lot of all the leaves, branches, CO2 is emitted. So, or if you collect fuel wood in a non-sustainable way and use it for cooking, you are emitting CO2. So there is a both sequestration in trees and soil, stocking the carbon, and other is of course emission due to burning or land use change and all that.
Right, and this sequestration and the changes in its capacity, is that what we call carbon flux, and is that something that we are studying? How are we studying it?
Yeah, no, as I said, we take there is in fact we have to do every 2 years. Government of India has to submit what are called emissions inventory to the UNFCCC. All countries under the Paris Agreement, under the UNFCCC, all countries are obligated to submit periodically their carbon inventory or greenhouse gas inventory. So India is doing. We do for all the land category. As I told you, we take the whole 320 million hectares of, like a wall to wall inventory. We do forest land, cropland, grassland, wetland, settlements, deserts. We take all of them. We estimate the carbon. There are some standard methods, procedures, models available. So using them, we estimate inventory stock change. Normally, if a forest or a grassland, if you disturb it, go on. If you disturb and after that take soil measurements, it will be less than before you go and disturb the grassland. Same with the cropland. Before you plow, you take this soil carbon. If you plow and disturb and leave it for some time, due to sunlight and presence of oxygen, CO2 goes back from organic matter in the soil. So we have some standard procedures, methods developed by Intergovernmental Panel on Climate Change (IPCC), so that all countries use the same comparable methods. India, China, Philippines, Brazil, US, China, everyone uses a identical similar method, similar protocols. So these guidelines would help all countries to prepare the inventory, carbon stocks, stock change, emissions. All of that will be done using some standard procedures, methods, and guidelines prepared by uh, IPCC for the UNFCCC.
Right. Can you tell us a little bit more about the models that are used? So, is there a vegetation model or a forest model that is used specifically in the Indian context?
In India, we are not yet using models for estimating carbon stock change, but we're using models to assess the impact of climate change and forest ecosystems. How, if there is a 2-degree warming, 3-degree warming in the next 50 years, 100 years, how forests in Western Ghats, how forests in Himalayas, how forests in central India would respond. To assess the impact of climate change, we use models. We are not yet using models to assess, the carbon stock change in forests, grassland, or agricultural land. But many other countries like Canada, US, Australia, UK, they are using models. But we are still trying to develop our own models and use them for monitoring, estimation, even projecting carbon stock changes or emissions and sequestration using models. But currently at University of Science and one or two other institutions, we are using what are called dynamic vegetation model to assess the impact of climate change on biodiversity, on carbon stock in forests in next 30 years, 50 years, and so on.
And what have these models revealed so far? Is there
Yes, we have done published many papers from Institute of Science. My students have worked at Institute of Science. We show that using what they call moderate emission scenario and high emission scenario, we showed that anywhere between 20 to 30 to 35% of forests may undergo change in the next 30 to 50 years. That means the future climate is not suitable to vegetation that exists today. If you take the Western Ghats, all over from Kerala to Maharashtra, Goa, Karnataka, including the vegetation, the biodiversity that exists today is adapted to the current climate or the last climate of the last maybe 100, 200, 500,000 years. But now the climate may change in the next 30 to 50 years, becoming warmer and changes in rainfall pattern. Forests may not be able to cope with this change. That means there could be what we call dieback. Forest trees may wilt, they may not grow at all, they may die finally one day. So that we call some sort of the future climate will not be suitable to the biodiversity that exists, the forests, evergreen forests that exist in Western Ghats and the Himalayan forests that exist, in Uttarakhand, Himachal Pradesh, and so on. So that's what we know currently.
right? In terms of the potential of forests as mitigators, it is well known, it is well recognized, it's even part of our nationally determined contributions to increase forest cover, and all of those things are out there. But in layperson terms, what does this translate to? So, how many forests, how many trees is it required for us to reach an ideal state? That's one. And beyond that, what can we do to ensure that the conditions are conducive for these forests to continue thriving and succeeding?
Yeah, what India has committed, it's a voluntary commitment.
Correct.
It's called that. That's why it's called nationally determined contributions to reduce global warming. So all countries, every country, all the 195 countries on the United Nations have submitted their voluntary targets. To reduce how much electricity you want to have from renewables, what's the changes in carbon intensity of GDP, and how much carbon you would sequester in forests. Government of India submitted in 2015 and again updated in 2022. Again, they have to periodically update probably later this year. India has committed that they will sequester or store or create a sink of carbon, in forests and trees, including soils, the 2.5 to 3 billion tons or gigatons of CO2 by 2030. Taking 2005 as a base, you have to start from some place. Compared to that, we had so much stock in 2005. By 2030, the stock has increased or decreased. That's how we measure. So we know the carbon stock in 2005, maybe roughly around 7,500 million tons of stock C. And then we have to increase that by 2.5 to 3 billion tons of CO2. That means roughly one third of it is a carbon. So roughly about 800 million tons of C is equal to about 2.5 to 3 billion tons of CO2. So we need to sequester through what they call additional forest cover and tree cover and additional carbon sink. So there are two components which Government of India's official submission to the United Nations clearly states that will create additional tree cover, means planting trees, on the roads or in farms and so on avenues, along railway line or along highways, on farms. You can plant trees and also grow plantations. It could be teak plantation, mahua plantations, sal plantations, or mango plantations. So including both increasing forest cover and tree cover will that is additional, in the sense what exists we won't take it. We'll create new forests, we plant new trees, plantations, and sequester in that about 2.5 to 3 billion tons. According to our estimates, if you have to really create a additional tree cover, additional forest cover, additional carbon sink, in the sense when you grow a tree, it takes CO2 from atmosphere, it stores as organic matter in leaves, in trunk, and in roots. And when the leaves fall, branches fall into soil, they become organic matter that stays in the soil. So the carbon is sequestered through this process, through photosynthesis, and it's transferred to roots, branches, leaves, and finally to soil. So that's how that means this 2.5 to 3 billion tons of carbon should be sequestered in trees, branches, leaves, and roots and soil carbon. That's what we have to achieve. But it looks like Government of India has some is trying to think whether we should really talk about additional tree cover and forest cover. That means you have to grow new trees and new plantations. Government of India, no, we'll just create additional 2.5 to 3 billion tons of carbon CO2 stock. Even that means including existing forests also sequester. Forests all over the world, every year they have leaves. They undergo photosynthesis, they sequester carbon, and some carbon CO2 also is emitted during respiration, and so on and so forth. So there is a continuous flux of taking CO2 during photosynthesis and emission of CO2 during respiration and decomposition. When leaves fall on the ground, they die, decompose, CO2 goes back. So there is a cycle of uptake and release of CO2. So even existing forests take carbon. All forests, otherwise they would have been dead and gone long ago. Because every year there will be some, let's say there is a fire, forest fire. But you go after 1 year, after the rainy season, all the branches have grown. So that means they are sequestering carbon. So Government of India wants to probably say that we'll also use the carbon sequestered by the existing forests in Western Ghats, Himalayas, teak forests in Central India, sal forests in West Bengal, Orissa. So using that, probably India will easily achieve the targeted sink creation. We call carbon sink in trees and soil. So India will easily achieve 2.5 to 3 billion tons of sink if they take existing forests also. All the like even mango trees, tamarind trees, on farms, they also grow. They also sequester carbon. They grow in thickness, more branches every year. But if we exclude that, if you want to really go for additional tree cover, additional forest cover, then you need to plant anywhere between about 15 million hectares under plantations and 15 million hectares under agroforestry like mango, coconut, apple, cashew, whatever, all the trees, tamarind, jackfruit, all those trees you can also include in agroforestry. So you need 15 million hectares under plantations and 15 million hectares have been under fruit trees and agroforestry. That we are not doing. That the targets, there are targets, but unfortunately we are not undertaking so much afforestation, new tree plantation, new plantation forestry we are not doing.
Right. In terms of, so earlier you had mentioned that we are yet to develop our own models to study what the impact of climate change is on forests and how forests contribute. As the expert in the field, what do you feel most excited about any of these upcoming technologies? Anything else that is on the horizon to study the impact of climate change on forests?
Of course, firstly, uh, we have India is very proud of biodiversity. We have Western Ghats forest, Himalayan forests, Northeast forest. They have storehouse of biodiversity. Forests are the number one host of biodiversity. Plants, birds, insects, bacteria, we name it. They're all there. So, but some of them are getting degraded for sure in India. So, given that, we need to currently we do not have long term monitoring studies in India, like whether in Europe or North America. There have been people have been studying forest permanent plots. Yeah, you set up permanent plots all over Canada, all over Sweden, all over UK, and under different soil climatic condition. You permanently protect them and go and monitor what's happening with the carbon, with pollination, with growth rates, regeneration, all kinds of physiological. They study that, but in India we do not have. So there are two ways. One is having permanent plots in evergreen forest, deciduous forest, plantations, in the sal forest, teak forest. Everywhere you can have permanent plots all over the country based on some protocol, some scientific approach, and monitor changes because climate is changing. Year to 1 year you have too much rain, 1 year too little rain, 1 year you have flood, 1 year you have drought. So climate change, forests also respond. May not be as quickly as crops. If there is no rainfall for 2 weeks, 3 weeks, paddy, maize, jawar, ragi, any crop would wilt. But forests, of course, because they have deep roots, they won't respond, but they do respond over a period of years. And we do not have long-term monitoring plots to assess how forests have been responding the last 30 years, 50 years. We don't know. We have just made a small beginning. But other countries have been monitoring how forests are responding, in the last 30, 40 years. Because in the 30, 40 years, climate has changed in whether US or Canada or India, Brazil, anywhere you go, climate is changing. It has changed significantly, temperature, rainfall pattern, and so on. So, how forests are responding, we are not, and we don't have that kind of monitoring plots and studies. But in the absence of that, we use models to project by what's the current climate and what kind of vegetation that exists under the current climate, in the Himalayas, in Western Ghats, in central India, and northeast. Different climate, different soil, and altitudes or latitude determine what type of forest you have. So what we do is we develop models for a given climate, given soil, and given other factors. This kind of forests exist today in the Western Ghats. If you go to Goa, Mangalore, Udupi, you have evergreen forests, Sirsi, Karwar, and all that. That Western Ghats, you have evergreen forest. Okay, if there is a warming of 2 degrees or 3 degrees by 2050, can evergreen forests in the Western Ghats survive? These models will tell you. Under current climate, you have these forests, this biodiversity. Under future climate, what biodiversity will have? Can the existing forest survive? So those models we are using. Unfortunately, we have not developed any models in India. We're using models developed in largely in Europe. So every model will have some limitations. So the models developed, in Europe are most suitable for temperate forests, boreal forests, colder forests. They're suitable for tropical forests, but we have limited data. So we need to India need to develop. It's such a large country with so much scientific manpower. We should be able to develop our own models suitable for forest types. In Sweden, UK, you may have only two, three forest types. In India, we have some 28 forest types, such diverse. You go to Western Ghats, every 5 kilometers, you find a different vegetation, tree mixture and all that. So, given such diversity, we need to develop our own models. We do not have them, but they are very important. That's one of the areas of research that we need to do.
Right. In terms of the indigenous populations and their knowledge of forest systems, so you had earlier mentioned how a lot of forests function as livelihood sources. In terms of the knowledge system of these communities, how much are we harnessing that to conserve our forests and what more can we do? in that sphere?
Traditionally, communities owned forests because we are talking about like 200 years ago, nobody owned. It's all communities who were using the forest, protecting the forests, and they were living inside the forest only. But now, of course, with population growth and all the modern civilization, people have moved out of forest. Most of the very small percent of Indian forests live in people live in the forest. So communities had a tradition of conserving biodiversity, protecting biodiversity, and using it more or less sustainably. But now, with the increasing population, increasing demand for fuel wood, timber, leaves, and you name it, name any product from the forest, there is over extraction of forests, and communities have lost control over the forest next door. If there is a village with 500 people or 1,000 people, they are taking care of the forest around them. They don't go very far. Within a walking distance, they would take care of the forest because they depended on forest for the livelihood, for the cattle, for the sheep, everything. So they would, but now forests are owned by the forest department. Government of India controls the forest. Sometimes they don't allow communities to enter the forests also. You can't take your cattle inside for grazing. Sometimes there are very strict rules on that. So given that communities have lost control over forests, but if you want to conserve forests, or if you want to uh, regenerate degraded forests, or if you want to undertake forestation in a community land, in villages also have some common lands. If you undertake, then you need to involve communities. So their knowledge would be very useful. What species to grow, they would know better than any scientist or a forest officer. So we need to know them. But traditionally, also for communities who are protecting, what are called Devar Kadu, or Devar means God's forest, and or sacred groves, as it's called. There are sacred groves all over the country in the past, but they all have disappeared. They used to they would protect a patch of forest as God's forest, sacred grove. No one would touch that. They would go during certain days in year. They would worship and do puja and all that. So that helped conserve biodiversity and forest all over the world. They say indigenous communities are very critical in the short term and in the long term to protect forests, to protect biodiversity, and also to conserve the carbon in the forests. It's a protected areas. All there's the tiger reserves. All these reserves are there. Even there also there are people living there, and you heard of the man wildlife conflict. So you have to work with communities to protect the existing forests and to regenerate new forests. So their role, their contribution is very critical. But same time, we need to ensure that they also get benefits, and they have some role. They have rights and roles, responsibilities, and also they should derive some benefits. After all, Government of India had one program called Joint Forest Management, where communities and forest department would jointly protect, manage. Every village would manage some patch under this joint forestry program. So the benefits from that would be shared, say 80% by the communities, 20% for the forest department, which will be again invested there. That kind of programs, policies we had, but somehow, in India, we launch a program, it takes off on its own, and after some time, people move away from, go to the new program.
Right. So you mentioned about European models having limitations when applied to Indian conditions. This question is in context with your experience as an IPCC author. How do you find the IPCC models apply to us at a granular level, so district level, village level? Does it apply well, or is there more that can be done in terms of the global models that are being shared?
Yeah, if you like, for example, assessing the risk or the vulnerability of communities or ecosystems, we all use IPCC framework, risk framework, their IPCC vulnerability framework. So now the way IPCC develops these framework, these methodologies, these guidelines, IPCC doesn't conduct its own research. I've been in IPCC for the last 20, 25 years. As an author of or a scientist of IPCC, we don't conduct research. We only synthesize all the published knowledge. All over the world, people, scientists in India, Brazil, China, US, UK, Germany, Japan, everybody's publishing papers, scientific, bring out technical reports, FAO, UN agency, they all international agencies, they do research, they publish reports, papers. So IPCC synthesizes periodically, once in 5 years, brings out a report. We already brought out six reports, first, second, third, fourth, sixth. I was involved in four of these out of the six reports. So every 4 to 5 years, 6 years, they bring out one report. So as the science evolves, because climate change is a new science compared to other traditional physics, chemistry, biology, and all of that, it's a new science. In the last 20, 30 years, it has exploded, and in the scientific world. So as science advances, new knowledge, new models are generated, prepared by scientists and published. IPCC synthesizes that. Let's say there are 10 studies. They use different types of models to or framework for assess the risk or vulnerability. Then we sit together, we look at all those 5 or 6 or 10 papers, see, take out the best from that and synthesize and come up with a consensus framework to assess vulnerability. But that method can be used, for example, there is a risk framework, there's a vulnerability framework developed by APCC. People use all over the world, students to professors to scientists, they use those. The advantage is that, using some common framework, you can understand vulnerability in Bangladesh, vulnerability in India, vulnerability in China, Japan. You can is relatively you understand what it means. So that method, that framework, that guideline, that model can be used to rank uh, the countries. You can take all the Asian countries and rank them on a vulnerability index. Japan, Philippines, you probably will end up Philippines, Bangladesh are the most vulnerable country. Maybe Japan, Korea will be least vulnerable. India may be in between, like that. But you can do the same. You can use the same framework to compare all the 28 or 29 Indian states. We have ranked the states. We showed, as I told you, Chhattisgarh, Jharkhand, Orissa. They are most vulnerable. Maharashtra, Himachal, Tamil Nadu are relatively. Everybody is vulnerable. It's always a relative concept. And we can use the same risk or vulnerability framework to rank the district within Karnataka. There are 30 districts in Karnataka. You can rank them to show, say, some districts in the northeast are most vulnerable because they're drought prone and so on and so forth. And you can also use it within a district to rank the village. There are 1,000 villages, which is the most, well, you may ask why do you need to assess the risk vulnerability? We all know everybody is vulnerable. Everybody is at risk of climate change, but some are more vulnerable, some are relatively less. If there is flooding in Bangalore or Hyderabad, only people living in rainfall is same. People living in low-lying areas are vulnerable to flood. People living in posh colonies, nice houses, apartment, they are not vulnerable to flood. Generally low-lying areas. So there'll be more malarias, more maybe slums and so on in such certain areas. They are more vulnerable to malaria or floods and so on. So if you take, we have some 600 off lakh villages, some 800, 900 districts. If government wants to invest money, limited money, to build adaptation capacity in communities, you want to go to the most vulnerable district, most vulnerable states. If Prime Minister wants to give some 1,000 crores, I don't think they have given so much money. If they want to give it to help people, poor people, to cope with climate change, drought, flood, cyclone, then where do you want to go? You can't go to all the 800 districts. 1,000 crores will be nothing for so they will ask people like us, give them, rank the districts in India. Out of 800 district, top 20 most vulnerable, top 50 most vulnerable, top 100, at the bottom 100 least vulnerable. So Prime Minister, the Chief Minister, or the Chief Secretary, or the ministers, okay, in Karnataka there are 30 districts, but if you take drought vulnerability, these three districts are most vulnerable to drought. Then you put your money, build capacity, adaptive capacity in the communities. It's the government job is to help the poorest, always. So that means you need to identify the most vulnerable communities, most vulnerable crops, most vulnerable districts, and put your adaptation resources there to help the poorest and the most vulnerable.
So, we've now established the importance of having a carbon sink, having policies that help build this carbon sink. Could you tell us a little bit more on some of the global as well as national schemes that encourage the building of the carbon sink among people?
Yeah, you've heard of Paris Agreement, which was signed in 2015. That has one article called Article 6, where you can uh, have projects in developing countries funded by UK or Germany or Canada, not US anymore now, but they can fund projects here, and say some British Airways or Lufthansa can fund a large afforestation project in Karnataka or Tamil Nadu, involving maybe 10,000 farmers. They grow some mango trees, tamarind trees, or the fruit trees, or teak trees, and so on. So they can sequester carbon, and communities get the benefit from mango fruits or even teak, some part of teak grown. But carbon sequestered in trees and soil could be bought by Lufthansa or British Airways or Jaguar, Land Rover automobile companies, or Mercedes Benz. They can buy those credits to meet their requirement in UK or Germany. But here communities get maybe $20 per ton of carbon sequestered, or maybe it could be even $50 per ton of CO2 sequestered in trees. Communities get the benefit. Or even if it is simply there is a degraded forest, you protect, communities protect, and trees grow, and people can get fodder and some fuel wood they can collect, but trees remain. And for that, communities get, for every ton of carbon stored or ton of CO2 stored in soil or vegetation, they get $20, $30, $50, like that. There are many projects around the world. So currently there are three, four major schemes. One is Article 6.4 under Paris Agreement provides opportunity. It took many years from 2015. It was the procedures, rules, protocols, verification, reporting, all of that. It took, imagine, from 2015 to 2024, it was agreed. So it has taken almost 10 years. Now the rules are being finalized, more or less agreed. Maybe within 1 or 2 years, there'll be Article 6.4 projects where rich countries can set up projects here. It could be wind energy, solar energy, or energy efficiency system, or forestry. Definitely forestry in developing countries. So they, as I told you, British Airways, Mercedes, anyone can invest in Tamil Nadu, Karnataka, Andhra Pradesh in a forest protection or forest restoration or a agroforestry project. They can buy credits and pay for that credit. So farmers, local communities get paid, and their soil is conserved, their water shed will be protected. There are local benefits also. There are global benefits. There are financial benefits to communities, farmers, and so on. So that is one global mechanism. Again, within India, Government of India recently announced two schemes. One is called Green Credit Program (GCP). Under that, if I say I'm living in a village, I and some 10 farmers together, we decide to plant trees on our farm, and we can register as 10 farmers together in a village or in group of villages, maybe like 5 hectares, 10 hectares, 20 hectares, 50 hectares. Okay, we are undertaking afforestation, we register as a project. And there is one agency in Dehradun. There is some procedures available on the website. I can register this, let us say, 10 hectares in one village. So then that somebody will come and verify that under the green credit program. And after, when the carbon is sequestered at some stage after 5 years, 10 years, somebody will verify and give the some money per, given the market price at that time. So we 10 farmers together, we have protected or raised 10 hectare forests. Government of India has some procedure to register, measure and verify, and then you get paid. That's green credit program. That is for small scale. It could be even big also, but largely it's meant to help individual farmer, a group of farmers, or group of villagers, or a panchayat to undertake greening programs. They get, farm communities get financial credit, products like leaves, fruits, and so on. Global community gets, or the, like Tata's can buy that carbon credit, or Mahindra can buy that. In all the companies in India, Reliance can buy those carbon credits from these thousands of such small ones. That's one program. Other one is carbon credit trading scheme. Government of India has set up a carbon credit trading scheme. It includes energy efficiency, renewables, some cement, steel industry, all those big industries. Also includes afforestation, reforestation, and biochar, incorporation soil. So there are many forest agriculture related activities can be taken up, and where let us say there's an NGO in Andhra Pradesh, they bring 100 villages together, they raise maybe 5,000 hectares of plantations or forests. They can have a negotiation with Tata Steel or Tata Chemicals or Telco, and they can sell credit to them, to Tata Steel, Tata, or any aluminum company or cement company, ACC. They can buy credit from this NGO, which put together these 10,000 farmers and 5,000 hectares. So Tata's or ACC Cement can buy credit. So this program also is available. So local communities get financial benefit. Mahindra, Tata's will get credit because they also have reduced their emissions. Tatas, Mahindras, everyone, Reliance, they have to reduce their emissions under the government scheme. So there is a benefit for global environment, benefit for communities. It helps the companies to meet their credit requirements. So that way there are some programs like that. In addition to that, there are programs such as MG Narega, Mahatma Gandhi Employment Guarantee Scheme. Under that, a lot of government spends 60 to 70,000 crores every year. One of the programs included in that is tree planting in especially in the, rain-fed areas, drought-prone areas. And we did a study. We showed that significant carbon is sequestered under the program, under the MG Narega at a national level. We made an assessment, showed significant CO2 sequestered. That's not the objective. Objective was to help provide employment, provide some social security to the poorest families in villages. But in the process, they are planting trees, they're sequestering carbon. So, and there's watershed program. Government of India has a large watershed program, all over the country. Under that, tree planting happens. There's agroforestry program. So there are many programs where tree planting is happening. So that's how our India is a some sort of a sink. The land use, according to estimates made by Ministry of Environment and Forest with the help of Institute of Science in National Remote Sensing Agency and Forest Survey of India and others, we made an estimate that Indian land mass, forest land, cropland, everything together is a net sink because of all these such initiatives. So there is a huge opportunity to earn some financial benefit for the poor farmers, drought-prone farmers, flood-prone farmers, and also generate many ecological benefits. When you grow tree, there'll be more birds, there's more biodiversity. You get more fruits and leaves. People eat all kinds of fruits, leaves, and the seeds collect. So there are a lot of multiple benefits. So I would say for any rupee or a dollar or a pound invested, if you invest in forestry, agroforestry, you get 10 times more ecological benefits, livelihood benefits, benefits for the poor, and global benefits. Unlike maybe you do it in the cement industry. We need both, but this is if you have $100, I'll first put it here so that you can get multiple benefits.
Right. That actually brings me to my next question. There is a lot of buzz around carbon credits and investing in carbon sequestration projects. But at the same time, a lot of private investment is hesitant because there is no solid framework to measure scalability or demonstrate scalability. What, in your opinion, could de risk some of these investments for them? What could give them the assurance that it's a good investment?
Yeah, no, there are many challenges. Okay, if, tomorrow Mahindra wants to invest maybe 500 crores on forestry program in Tamil Nadu or Karnataka, Andhra, anywhere. But he doesn't know where the land is. First problem would be, okay, he will identify three NGOs or forest department to say, I want to give you this 5,000 crores or 500 crores or 100 crores. I want to help. I want to buy the credit for my company, Mahindra or whatever. But firstly, we don't know where land is available. India's land, every land is owned by somebody, either some trust, farmers, trust, village communities, somebody is owning the land. So, firstly, someone wants to have a large project, we don't know where the land is at. That means you need a good land bank database. That is not available for any large scale project. Secondly, on forestry, there are legal challenges. Who owns, okay, the Mahindra invests or Tata's invest in a forestry program. We don't know who owns those trees, that carbon there in that land, maybe in the name of a farmer. But the carbon trees, there are some there's a legal problems involved here. There's a need for a clear legal framework to say if some project is taken, funded by some industry in some area, in some land, just a clear rule saying, okay, the land belongs to whoever is owning that, but some benefits farmers can use, some benefits companies can use. So that clear legal framework is missing because land ownership is always there are problems. We don't know if land means there's always a problem in India, whether it's for industry, for forestry, there are problems. Secondly, lack of permanence. The problem is you may grow trees. Let us say Mahindra or Tata's or somebody funds, then people overnight can cut trees. So there is then what happens to the carbon credit? But the company has taken this program in their portfolio to meet their commitment. And if farmers cut tree, then order, that's called the lack of permanence. There's no guarantee. Unlike if energy efficiency or renewables, if you save today, you have saved it forever. Instead of having You just have one solar panel, you disconnect from grid, you are every month you are saving 200 units under related CO2 emissions. But here there's a lack of permanence, so that's one thing. And thirdly, of course, is there are no incentives for the industry to invest. If I'm an industry, if I want to invest in the energy efficiency program, like distributing LED bulbs, than working with forestry, I will go easy because it's easy to distribute LED bulbs or set up some solar panels, because I can see, I can measure, quickly set up. Here there are many problems. You need land, you need to protect it, you need to prepare land, you have to, you need labor, you need water, you need seeds. There are so many there are many challenges in forestry compared to, say, setting up a solar panel or distributing LED bulbs. So most industry CSR funds will go there, in easier energy projects than in a forestry projects. So that means we need to create additional incentives to entice industry corporates to put in money into forestry and agroforestry, because they benefit the poor people, they benefit environment, they protect biodiversity, many benefits apart from carbon sequestration. So but currently there is no clear policy framework, legal framework, benefit sharing framework. Okay, there is some every year 10,000 rupees coming per hectare. There must be a clear benefit sharing mechanism. Farmers should not be cheated. Some company NGO may come, take away 80% of the carbon credit, leave only 20% to farmers. So benefit sharing framework, procedures, rules, and legal tenurial position. Who owns land? Who owns carbon credit? All tenurial system and incentives, and good monitoring mechanism. Again, it's not like you install a solar panel, you can easily measure how many units of electricity generated. If you replace a normal bulb with LED, easily any schoolboy can calculate, tell you how much electricity you are saving and how much carbon is saved. But in forestry, measuring, monitoring is not easy. If you take soil carbon, which is very important, I told you there will be more carbon in soil than in trees. Soil carbon has to measure once in 3 years, 5 years. And soil carbon varies from point to point. Within 1 hectare, you may get five values. So then which value you want to take? How will you, okay, you made, the carbon is stored today, but someone disclose the land, then carbon is gone, at least from the top layer. So there is a need for, there are mechanisms available, there are procedures available. IPCC, Intergovernmental Panel on Climate Change, has produced guidelines for measuring, monitoring, and reporting method. That's at a national level. Again, there are many agencies who have come up with simpler procedures for measurement, monitoring. Some are using satellite-based techniques. So systems are evolving, but still, it's still a difficult problem. There isn't any. This is a method. This one, no, there isn't one method. There are multiple methods. Again, it depends on the scale of the project. If it is a small one village, 10 hectares, you need one method. If it is 5,000 hectares, you need some other method. If it is agroforestry, you need one method. If it is protecting existing forests and increasing carbon stock, you need no, there are multiple methods, and all methods have some uncertainty, because you're dealing with nature. Some years it grows, some years trees don't grow much. So there could be fire, and even there could be a lightning, and there could be a fire. Forest fire, the trees could be burnt. So there are a lot of biological factor. There are a lot of uncertainty involved. So we need some simpler method, low cost, reliable, robust methods. Also required, one of the critical factors in really giving credibility to programs.
Sir, in our earlier segment, you spoke about how much more we can do to study the impact of climate change. My question is not just on forests, but all other aspects of climate change on our country. If you were to ask future climate researchers to focus on a bunch of topics, what would that be?
Firstly, agriculture is so important. 60 to 70% people depend directly or indirectly on agriculture. Agriculture is crop production is highly sensitive to droughts, delay in rainfall, too much rain. So we still do not have, despite having a large ICR, Indian Conservative Agriculture Research, large number of agriculture universities in the country, we still do not have good assessment of impact of climate change on rice production, on wheat production, on maize production, on pulses, on millets. We do not have good assessment. That's how I would say one of the first critical modeling, because you're talking about future. With we take the soil, water availability, and so on. with 1 degree warming, 1.5 degree warming, changes in temperature, changes in rainfall, changes in evapotranspiration demand, how crops would respond to can rice be grown, say, in some region? Can wheat be grown in some region in 20 years? The studies have shown that where wheat is grown today in some parts of central India, after 20, 30 years, you may not be able to grow wheat because change in temperature. Wheat is sensitive to temperature. Rice is sensitive to temperature. So there is a need for good assessment of impact of climate change based on high quality models, based on local soil, water, agriculture practice. That's, if you ask me, at a district level for dominant crops is very critical. That we don't have. There is some assessment available, but very national level. If you ask me, in Karnataka, is there a, or Andhra, is there a district level assessment of how climate change will impact rice or maize or whatever? No, I'm sorry, there's no study at all, honestly. And next is water availability. How climate change will impact water availability. Water depends on rain. Rain is impacted by climate change. How, when the with climate change, rainfall pattern would change. You may get too much rain in one season or too little rain on season. What we call JJS, June, July, August, September, is the main cropping season in most part of India. It's called Kharif or monsoon season. Some years you get good rain, June, July, all the 3, 4 months you get good rain, you get a fantastic crop. Farmers happy, everybody is happy, Prime Minister is happy, government is happy, because farmers are all happy. They have lot. In some years, you get all the rain June, July, no rain in August, whole of August. You have sown your groundnut and it dries if there is no rain for 3 to 4 weeks. Sometimes you don't get any rain in June, July. You get all your rain in August, September. You can't grow. So it's very challenging. So how farmers can cope with changing rainfall pattern? How to provide access to weather forecast? Rainfall forecast, and how to, what kind of crops, when to grow. Some action is happening, but that's not adequate at all. Farmers, I would say, not even 10% of farmers access what information is available. That information to help farmer to take decision what crops to grow, what variety. If you take groundnut, you have different length of period. If you take maize, you have 100-day maize, 130-day maize, 150-day or 90-day maize. Which there are 20 varieties of maize. Which variety to grow depending on when it rains, depending on the soil condition. So this kind of a good farmers advisory based on weather, soil, and other crops and so on. That kind of advisory is missing on agriculture. And water resources, again, water availability for drinking, for industrial purpose, for agriculture. That will be, with warming, crops demand more water, because when there's warming, we also drink more water. Crops also, with warming is guaranteed. Rainfall can vary, but warming is consistently, earth is becoming warmer and warmer and warmer every year, the global mean. So this kind of water management, water related, rainfall related, flood related, research is not happening. To be honest, climate change research in India in its infancy. Though we may claim so many things, but number of people working on climate change is minuscule. We need more people. We need people with increased modeling capacity, mathematical, statistical modeling knowledge capability. That's missing. So a lot of research has to happen in all aspects, in forecasting, in creating access to these forecasts, water management, crop management, forest management. All of them, we need more research for sure.
Sir, on that insightful note, thank you so much for your time. It was a very engaging conversation. If you like this conversation, follow and subscribe to the Boring Climate Podcast.